In this video, we'll talk about polar coordinates, kind of where they come from, and then how to convert between polar coordinates and Cartesian coordinates. So before we talk about polar coordinates, let's review really quick Cartesian coordinates. So this is a fancy term for our standard XY coordinate plane. Okay, so quick review. We have a y-axis and an x-axis. And if we think about the point 3, -4, well, that means we go to the right 3 units and down 4 units, and that would be our point. And it's a way of locating something from a reference point, usually we call it the origin, and we go left or right some amount and up or down some amount. It's a way of discerning a location by giving essentially a grid perspective to it. Now this is all review. Now let's talk about polar coordinates and how they're a little bit different. So polar coordinates, the whole idea at its core is I'm going to look at our origin, as we do, and I'm going to look at whatever this point is. And instead of going how much did I go to the right and how much did I go up with our standard x and y coordinate plane, the idea is, okay, how far would it go in a straight line? Now this is very similar to vectors. We're given a distance and some kind of angle, usually marked as a theta. So polar coordinates are given as how far, r, and at what angle, which direction, theta. Very similar to vectors. So the idea is we're not so much giving the idea of like a coordinate. So a way of explaining this would be if you look at a globe. We have a lot of ways of explaining to somebody where to go. One example of how to describe a location is involving a latitude and a longitude line. We're essentially assigning grid points to the world. Or, as an example towards more like the polar coordinate idea, you can say, okay, you have to drive 60 miles going east to get to where you want to go. That'd be more of a polar coordinate. It's a little more relative, but it is just as exact as the y and x. And really, it's just another way of doing things. So the big thing we'll talk about here with this lesson is how to convert between the two. So if we look at a coordinate, let's just kind of work it out in general here. There's two ways we can do conversions. One involves formulas and the other involves more of drawing pictures and doing the thinking. Now I don't care which one you use. It's entirely up to you. I will go through both and I'll do an example of each to kind of show you where it's coming from. So if we think about a coordinate, I'll do the Cartesian style in red. Now something that's worth noting for our polar coordinates is that the x-axis, that's our 0-degree line. The y-axis up here, that's our 90-degree line, and we have 180 degrees here, and we have 270 here, and then if we go back to the 0, we go around, this would be a positive rotation. And then something else that's worth noting, if I go the other way, that'd be a negative rotation. So it's opposite of what you would think with clockwise. A counterclockwise is positive rotation, and clockwise is negative rotation. So in this regard, if we think about an angle on the coordinate grid, 270 degrees is the exact same thing as -90 degrees. So just a side note on the polar coordinates, at least as far as the direction goes. So if we're looking at, back to our example here, we have an x, we have a y, and we know this to be a right angle by nature. If we are looking at the polar coordinates, which I will do in green, we want to know the distance and what direction. Now there are lots of ways we can do some converting here to figure out relationships between these two. So quick knee-jerk reaction, an equation I'm seeing is using Pythagorean theorem because we are looking at a right triangle. You can say r squared is equal to x squared plus y squared. And then by extension you could say r is equal to the square root of x squared plus y squared. So you do the squaring, or the adding first after the squaring, then take the square root after you're done. It's just essentially the next step in the algebra. You can use either one of these two. So if we're given x and y, we can figure out what r is using that yellow equation. And then likewise, we can set up a similar equation for theta, given our x and our y. I would think, since if we're looking at x, that's our adjacent, y is our opposite, theta, or in particular the tangent of theta, is going to equal y, the opposite, over x. And this way, if I'm given theta, I can figure out what, or if I'm given x and y, I can figure out what theta is. So theta is going to equal the inverse tangent of y over x. Okay? And then, if we think about going the other way, if I'm given a polar coordinate and I want to make it Cartesian, I will know the r and the theta. How can I get to x and y? Well, if we know, essentially this would be the hypotenuse of my right triangle, and this would be the angle of my right triangle, I just have to set up essentially a sine and a cosine equation. So, if we think about sine of theta, that's going to equal y over r, which if I multiply both sides by r, I get r times the sine of theta equals y. And then likewise, I can follow a very similar result to figure out what x is. It'll just be a cosine. So x will equal r times the cosine of theta. Now this is deriving the formulas. On the next slide I'll have just a simple formula sheet for you, and I'll show you both ways of doing it. One where you can essentially do the derivations, you can go through, figure out, okay, make your right triangle, do your sine, cosine, figure out what you need to know. I'll do that one first, and then I'll show you the formula approach. So here's the formulas summed up, and if you take nothing else from this video, you can write this down. If I'm going from a Cartesian coordinate to a polar coordinate, I've outlined those with the red. So in this case, I would know the x and y. I'd be given that, and I want to go to a polar coordinate, r then theta. That's where I'd use the red equations, and then from polar coordinates to Cartesian, that's where I'd use the blue equations. I'd be given my r and my theta, and I want to know what x and y are. So if you need to pause, write these formulas down, feel free to do so here. I'll go through a couple of examples immediately after this to show you both ways of doing it. So let's do an example. So if I'm given the coordinate as a polar coordinate, 5 and 20 degrees, and I want to convert that to a Cartesian coordinate. Well, the first way I would do this is first, let's take a visual approach before we take the formula approach. So I'm going to recreate this. What this is telling me is that I go 5 units away from the origin in total distance, and it's at an angle of 20 degrees. So I'm thinking 20 degrees is going to go up from the x-axis, something like so. And I know this distance to be 5 units. Now, ultimately, what I'm looking for is the y-coordinate here and the x-coordinate here. And once I find those, then I can make my coordinate. So if I'm looking at this, I have a right triangle, and let's say I want to solve for y first. Okay, I know the hypotenuse, I have this angle, and I want to find y, which in this case would be the opposite. So which trigonometric ratio involves opposite and hypotenuse? That'd be sine. So I know sine of 20 degrees is equal to y over 5, which then I can multiply both sides by 5 to get y by itself. So y is going to equal 5 sine of 20 degrees. I punch that into a calculator, that'd be my y-coordinate. Okay, now let's talk about how to solve for x. Similar kind of deal. X is the adjacent, 5 is the hypotenuse. I know the angle is 20 degrees. I would use cosine in this case. So cosine of 20 degrees is going to be equal to x over 5. And then I multiply both sides by 5. I get 5 times the cosine of 20 degrees equals x. Again, I run to my calculator, and then ultimately my solution I would give as an ordered pair. So it'd be whatever 5 times the cosine of 20 degrees is, followed by the expression of 5 sine of 20 degrees. And it's okay if they're negative. That just means that it'll have gone up and down. In this case, we can expect both of them to be positive. Now, I like the visual approach because it does help you discern whether or not it should be a positive or a negative number very easily. If you go with just the formula approach, sometimes it can be tough to tell. So, this is one method. We'll talk about another one here in just a second. Okay, now we're looking at a Cartesian coordinate going back into a polar coordinate. Okay, so on this one, I'll take the more formalized approach. I have an x and a y, and I want to go to an r and a theta. Okay, so if I'm trying to figure out what r is, I know that r is equal to the square root of x squared, which is going to be negative 3 in parentheses squared, plus y squared, so 4 squared, which we can do a little simplification here, and we can say this is going to be 9, or the square root of 9 plus 16, which is the square root of 25, so then r is 5. There's no need to worry about a negative in this case because r is a distance. It will always be positive. So I've got r, and then theta, very similar. Theta will equal the inverse tangent, if I'm using the formula approach, of 4, because that's what the y-coordinate is, divided by negative 3, which is the x-coordinate. Now, the negative is very important here. This will tell you what your angle is. If you don't put in that negative, it's going to be off. It'll be in the wrong quadrant, essentially. So if I run to my calculator, I punch this in with whatever I have and make sure you're in degree mode. And then ultimately I will give my solution in terms of r, then theta. So it'll be 5, and then whatever I get from my calculator for the expression of tangent inverse of 4 over negative 3. So converting from polar to Cartesian coordinates, really you use Pythagorean theorem and right triangle trig, and whichever method you use is just fine. You don't have to do the formula approach if you don't necessarily like it. So if you're more of a formula thinker, the formulas will probably be useful for you. However, if you're more of a visual thinker, the pictures, the visual approach would be more beneficial for you. Whichever one you choose is up to you. I just wanted to show you both of them. That way you have the freedom to choose.